Welcome back again for our continued adventure through 5-3, solving polynomials. So far we've covered what to do when there's a GCF, what to do when you have four terms, what to do when you have a sum or difference of cubes. Today we're going to talk about what do you do when you have a quartic that looks like a quadratic. Okay, so again, fourth method of factoring. Now, what do I mean when I say quartic? Well, hopefully you remember quartic means degree 4. Okay, and what we're looking at when I say looks like a quadratic is I'm talking about it has three terms. It has an x to the fourth term, an x squared term, and a constant term. And the way those are going to factor is factor x squared plus something, x squared plus something, or of course those could be minuses depending on the signs in the original problem. Okay, so this is actually super easy when you recognize what you're doing. Again, this is actually almost chapter 4 factoring, okay? It's almost literally basic factoring. The only difference is when I'm getting my two parentheses, how do I get an x to the 4? Well, I don't want an x and an x anymore. What I want is an x squared and an x squared. Once you recognize that, now the rest of it actually just kind of falls into place. How do I multiply to 9 and add to negative 10? Well, I can multiply to 9, add to negative 10 is going to be a negative 1 and a negative 9. Okay, so quite literally, the only thing you need to remember is you're going to be using x squareds to get an x to the 4. But then the factoring itself is actually the same as what you've been doing since back in Expo, okay? Now I need to recognize each of these pieces has to be 0, right? And the cool thing about these are even the pieces of it, well now you can always factor these using square rooting. Add the 1 over, square root, and you need to remember when you square root, you get a plus or minus. Here, add the 9 over, square root to give you plus or minus. All right. So now some of you might be saying, well, you could do this another way. So you don't have to write this down, but I do want you to recognize that this right here is a sum or difference of square, or is a difference of squares. That is a difference of squares. And so that's actually another way you could get each of those solutions of negative 1, 1, negative 3, and 3. So also recognize that these can potentially factor sometimes, okay? Not always break down again, but you could see this as more factoring if you didn't want to always have to do the square rooting method, okay? So let's take a look at this next one. How can I break that up? Well, again, to get an x to the 4, I'm going to need an x squared and an x squared. And this time, to multiply to 12 and add to 7, I'm going to get that. Now, neither of these factor again, so I can't do kind of that secondary method that I just showed you on the first one, right? This one, literally all you can do is set each piece equal to 0 and solve from there. So subtract the 4. When I square root, I get plus or minus. I'm square rooting a negative, which is going to be I. The square root of 4 is 2, so that's where I'm going to get plus or minus 2i there. Here, subtract the 3. I go to square root, which automatically means I'm getting a plus or minus. And now that the negative means I'm going to get an I. Square root of 3 doesn't simplify at all. So I'm getting that as my solution. So I want you to think here, okay? So how can you generalize a factor that's going to give you real numbers? So here, these gave me real numbers, real solutions, right? So I'm hoping that what you recognize is to get real solutions, you're going to have x squared minus something. These gave you imaginary solutions. So imaginary solutions are going to come from x squared plus something. So hopefully you begin to recognize how those factors relate to the solutions that they're giving you. Okay, an x squared plus a number, that's going to give you an imaginary solution. X squared minus a number is going to give you a real solution. Okay, that's going to help you recognize when you should be getting real versus when you should be using the eyes for imaginary. Oh, I'm sorry. So let's talk about this. Now, before you can factor, something very important has to happen here. Okay, so the very important thing that has to happen here is you need to make sure that they're set equal to 0. So the first thing that we need to make sure we remember to do is subtract off that 25. Okay, now we have a quartic that looks like a quadratic. So let's factor this thing. How can I get something that multiplies to negative 25, adds to negative 24? Oh, and that needs to be a squared. I apologize. All right. Now looking at this, something that some of you may recognize is this can actually factor again, right? A difference of squares. Oh, right? That is actually a difference of squares for you. Okay, so sometimes, remember, you could factor that piece again. Now, why doesn't this one? Well, because that's not a difference of squares. Whenever you have a plus there, you know there's absolutely nothing else you could do. Okay, so how does that help us? Well, because this gives us x equals negative 5, that gives us x equals plus 5, which again, you can see are the solutions of that. So if you wanted to, you could just solve that by square rooting if you had wanted to. That would give you that same plus or minus 5. So recognize that kind of has two different ways you could have gone about getting that plus or minus 5. You could have factored it a second time, or you could have just done that square rooting. This one over here, that one doesn't have a choice. Okay, that one does not continue to break down. So this one, the only way that you can finish it off is that square rooting method. Okay, whenever you square root, you always get plus or minus. Negative means I. Well, and the square root of 1 is actually just 1. So this one, the square root of negative 1, is really just giving you the plus or minus I. Okay, and that's how you're getting your 4 solutions. All right, this one right here, again, same story. You need to make sure that whenever you factor, it's set equal to 0. Okay, so you have to make sure that that's the case. And here, x squared, x squared. So multiply to 49, add to negative 14. Sounds like both of them are going to be a -7. Now here, even though it's a difference, 7 is not a perfect square, so it's not like we can call this a difference of squares, right? So this one, really the only way we can solve this is by saying, hey, I need each piece to be equal to 0. Now, in this instance, if you notice, both pieces are actually the same thing, so I really only have to solve it once, right? But because it was represented in 2 parentheses, really what that means is both of these solutions have a multiplicity of 2 because it came from 2 of the same parenthesis, so those same solutions are represented multiple times, okay? Because if you solve the same thing twice, you're going to get the same solutions, but that's what the multiplicity is telling us, that those same solutions are represented multiple times. All right, and let's take a look at this one. So this is a challenge problem because the first thing you should notice is actually an x pulls out. So that's what kind of makes this a more challenging one, is because you have to know that the x pulls out, and now you have to know that this factors. X squared, x squared. So you're going to get a +4 and a -1. And hopefully you guys can recognize that x squared minus 1, that can actually break down even further. That is a difference of squares. So you could break it up into its 2 pieces, right? So here that's going to give us x equals 0, x equals -1, x equals 1. This one, of course, is going to take a little bit more work. So I square root a negative. That's going to give me plus or minus. The negative means I need an I. Square root of 4 is just 2. So I'm going to get plus or minus 2i. Now again, I'm showing you to remind you that these can continue factoring, but of course, if you just wanted to solve that by square rooting instead of factoring it again, you do end up getting the same plus or minus 1, right? So again, I've been showing that all along to show you your options, right? You can continue to factor difference of square, or you could always use square rooting. It really doesn't matter to me. I just like to show you that you have multiple options to get to all of your solutions, okay? So that is the end of our notes. Again, hopefully relatively painless because the factoring method used here is really just like the ones you've already seen. So please make sure, take a moment to write that summary for me, and then come back ready to work on the practice work.